as people were saying, you may notice some Red Dwarf references throughout this presentation because Talkie Toaster was from Red Dwarf. So anybody who hasn't watched Red Dwarf, I don't apologise. You should go watch it. So what is it? Well, I saw on a number of places, saw people doing projects to make Talkie Toaster. And there was 2 versions of Talkie Toaster in Red Dwarf. It appeared in the first series, and then I think season 3, and it appeared in 2 different forms. So you can see both forms here. And these are people who've decided to recreate it in some form or other. So the top right one, they actually created it out of paper somehow. It was pretty realistic looking. And I thought, well, that's cool, but not really what I want to do. And then the other one is, it's basically a soundboard. You click it and it plays something at random, which was like, well, that's cool, but again, not really what I want to do. See, I'm not, I had a great idea, but with 2 minor flaws. I don't have any skills at creating physical objects, and I don't have any skills at creating physical objects. Now, I realised that technically speaking, that's one flaw, but I thought it was such a big one, it was worth mentioning twice. So I decided instead that actually what I wanted to do was a more interactive thing around using a Raspberry Pi to do voice recognition. And I wanted it to basically be able to have a 2-way conversation with it rather than it just being play random clips when you press a button or walk past it or something like that. And to do that, I needed to think about what I wanted from voice recognition. Key thing for me was I wanted to work offline because I don't want it dependent on an internet connection to do every single little thing. There's some APIs from Google and Amazon that allow you to do voice recognition really, really well. That's what your personal assistants use. So they do a really good job, but they send everything to the internet. The other thing is that I wanted to run constantly. So I wanted to continuously listen and make a decision on if it was going to say something or do something. And not just listen for a single wake-up word. So a lot of the time what these systems do is they listen for their one specialist wake-up word and then listen after that. I wanted this to have a kind of flowing conversation, so you could actually say different things to it and it would respond to them. So multiple wake-up words almost. And one of the problems is with those APIs is they only support a limited number of requests. So when you're using the free API, you can't continuously stream audio to it. You have to be very selective about what you send. And of course, I wanted to run on something low enough powered as a Raspberry Pi and still be effective. And a lot of the time when I was looking at these, my initial kind of Google search came out with a whole load of things that were more focused around what is a personal assistant kind of scenario rather than just a voice recognition system. And when I delved into it a bit further, I realized that most of these personal assistant tools had an underlying voice recognition system that they utilized, and you use different mechanisms. Quite often they would do the wake up call using one system and then do the voice recognition offloading it to one of the online APIs. So I kind of scrapped all of those and I narrowed it down over time to a series of 3 different libraries. So these were, I started with Snowboy. That was very good, but I'll go on to talk through these a bit more. Then I moved on to Pocket Sphinx, and that was less accurate, but was more flexible. And then finally onto Frasca API, which is the one that I ended up using to kind of make the project work. So Snowboy was quite interesting. What that does is it's really, really good at training to your voice. So what you do is you take 3 voice captures of saying the word or phrase that you want it to work with. You upload those 3 captures to them. they then generate you an identification file that you can then download and run. And you can load multiple identification files simultaneously, so you can have it listening to, say, 20 different triggers if you want it to. So that was quite effective, until I discovered one minor flaw, which was that it only recognized my voice because I trained it and no one else's. So everybody else who was trying to activate the speech recognition, it just ignored. It just didn't recognize them. So the only way to make it work with more people is to use the generic wake-up words that they already have, which have over 500 instances of different people saying it. So the neural net kind of can understand it. So that kind of didn't really work for what I wanted to do, because I wanted this to work for anybody. It had some really good plus points though. It was very accurate, very low CPU usage. And it's pretty simple to train, pretty simple to make it work. It's just that it only worked for me, so that made it useless. Then I tried Pocket Sphinx, which seemed to be very common. It needed a lot of tuning. So though you don't need to train it, it seems to need tuning to the microphone you use, to your accent, to all sorts of things. And I had a fair bit of trouble making it work reliably. It was detecting random words just from me pressing keys on a keyboard, which wasn't particularly helpful. And then I moved on to Frasca API. Now, Frasca API works really, really well for what it is. So no training, no customization. I didn't need to do anything to make it work. And it was out the box producing really accurate voice recognition. The only drawback is it's a bit laggy and it's quite heavy on the CPU. I tried it on a Pi Zero, and about a minute later it gave me what it recognized. So pretty useless in an instantaneous thing, but works well on a 3, works really well on a 4. It listens to whole phrases. So rather than trying to identify each word as you're saying it, it listens to everything, works out when you've finished speaking, and then gives a complete translation of exactly what it heard as text. So it's really effective at that. But that in turn means it's a little bit laggy at times. So what did I use to make this work? Well, I needed USB things, and these were on my desk. So I plugged them into the Raspberry Pi, and got it up and running. So the speaker and microphone, yeah, they both worked really well. The only problem was that occasionally the speakers would just stop working, and I'd have to reboot them. They've never done that on my PC, so I don't know what's going on there. Maybe there's something about USB sound on the Pi. Maybe there's just an interaction between them, but just didn't work. So yeah, and the other thing I noticed, the microphone was way too directional. You need to be really close to it to make it work. So it didn't work for my intended purpose, which is somebody speaking in the room. So what are we going to do with them, Mr. Flipple? We're going to get rid of them and get something far better. So I got both of these to test them out to see what would work best. And so the ReSpeaker 4 has 4 independent microphones. It sits perfectly over a Pi and works really well. But to be honest with you, it's probably not the best solution. The ReSpeaker 2 was more than ample. The 2 microphones were good enough quality for what I was trying to do. Seemed to pick up from most of the room quite effectively. And the big thing for me was it had a direct drive speaker. So it meant that you could plug a speaker straight into it and it would be able to play the audio out there as well. So it acts as an input and output device. Thing to know about both of these is that they consume the I2S bus. You only have one. So you can only have one active I2S device on you connected to the Pi. So you have to accept that either you can have one or the other. And if you've got an audio output device, you can't use the ReSpeaker 4 and the audio output device that sits on I2S. So your output then relies on the headphone jack or the HDMI out. So ReSpeaker 2 is perfect for what I need because I want to drive a speaker. So this sits independently and can react independently. It's also got a handy button, so that the idea being that in a finished device, maybe I'd remap that to a different GPIO, and that could be on a PIR. So when after a certain number of people walk past it, it's just going to chirp in anyway and just say something. Both of these devices aren't supported natively by the Raspberry Pi, the Raspbian kernel. Instead, you have to compile in the drivers into the kernel. Fortunately, the maker of these, Seed Studios, has created a really easy install process with a pre-compiled kernel. So you run a command, and it will download all of the updates that you need to then run the devices. So install problems. There's many ways to install the libraries that I've mentioned. I spent lots of wasted time installing libraries manually, only to find they had an automated install process. So do have a look around. All three can be installed using pretty much like pip install and things like that. And a couple of them did seem to not quite get all the dependencies they needed, and I had to faff around a little bit with that. Had a weird problem with ALSA crashing. So the fix for that was to install Pulse Audio, and most of the libraries will jump to using Pulse Audio instead of ALSA directly, and that just seemed to solve the problem. I have no idea why, but at that point ALSA didn't crash anymore. You have to make sure you pick the right audio device ID. So there's a whole, all of the libraries I've mentioned have a lot of information about how you pick the right devices, because you're going to want to make sure that your output device is the one you want and your input device is the one that you want. So what is it? Just kidding. Again, Red Dwarf reference, sorry everyone. So I started writing the code to make a nice little tweet, interactive system. So with Snowboy, it was really easy to do, but I had to hard code it because I had to record every single thing I wanted it to trigger on. So that became a very hard coded script. And then when I went to Pocket Sphinx, I didn't want to hard code it. So I created a JSON config file format that I could then use to be really flexible about what I picked up. The way that Pocket Sphinx works is you have to tell it what keywords you want it to listen to, and it really only works with about 8 to 12 characters. It's a certain number of syllables, but there's an optimal number that it will trigger on correctly. So what I had to do was build a keyword list up at the start of the program, shove that all into Pocket Sphinx so it knew what to expect and listen to, and from there it would then react to trigger words that it received. When I went to Frasca API, it kind of changed a bit. I removed things like Pocket Sphinx has a like a confidence level against each keyword that you set. Vosk didn't need that and didn't require a keyword list. So what I did was I mainly focused on making it work better, making more conversation paths and making it more flexible. So here's a simple JSON file from a project. So there's a section called sequences and one called toast. These sequences is important. Toast doesn't matter. It's just so I know what it is. Step one, the detection method is looking for an in-sentence thing. Apologies if there's any spelling errors in these because I was doing this in the middle of the night half the time and made plenty of errors. So what it's looking for is any one of these three keywords, because it says number required 1, keywords, and it's looking for any of those three. And then the action is to play a particular sample. The priority number is important. We've got this at priority 1, which is the lowest priority level. Because it's such a simple trigger, I don't want it accidentally triggering when there's a more accurate, more sort of relevant interaction that could trigger it. So this gets the lowest priority. This is a more complex interaction. So if it's question, and step 1 is listen to any combination of these two. So it's looking for 2 of those keywords to be triggered within the same sentence. So because Vosk provides everything as one complete sentence and not as it hears the words, you can then look for certain trigger words, and then it will play all of the actions unless the action method is random, in which case it will just pick one of them and play that one at random. And then it will go on to step 2 after that, unless it's got a step override. And then if it happened to play step 3, which was, would you like some toast? It would then go into whatever sequence toast is and start from step number 2 of that, and so on. So it's a way for it to jump around and so on. So next, play 11 was any question. So it goes to any question step 2, and you can see on the right hand panel you've got any question and then step 2, and it's now looking for those keywords to be spoken. So it's kind of jumped into a different work stream of sort of interaction stream, and again it's then listening to for a series of words or any one of them. And the timeout is simply that if it doesn't hear anything in that time, in those few seconds, it will then give up and go back to listening to anything with a step 1. So step 1 on all of them is active, and then when it gets a trigger on a step 1 of any of them, it will go on to step 2 of just that one, and then when the timeout occurs, it will jump back to step 1 of any of them again. So yeah, I'm not pished. So what could possibly go wrong with a practical demo at this stage? So let me see if I can. Okay, can everyone see that okay? Cool, can see some nods. So what I'm going to do is I will hit.
Howdy doodly do. Talkie Toaster, your chirpy breakfast companion. Talkie's the name, toasting's the game. Anyone like any toast?
So it's now listening to my voice, and when I stop speaking, it should give a translation of that sentence. So you can see there at the bottom of the screen, it's kind of picked up a whole load of stuff that I've said, and it's recognizing it. It's doing quite a good job, but it's not perfect. Now, if I was to mention, for example, does anybody want some toast?
Did someone say they wanted toast?
Yes. It doesn't know what to do about that because it's always refused normally. So if I say...
how about a muffin?
Oh, there we go. It comes up with all sorts of things. You can say things like, ask me a question. Ask me a question. It keeps misdetecting that. These are one of the things I need to kind of improve on, is the misdetections, and add them to the keyword list. So ask me a question.
Why have you got an IQ of 12,000 when it was supposed to return and level out at 6?
Oh, ask me a question, any question.
Any question?
Yes.
How to break the speed of light? How to marry quantum mechanics and classical physics? Any question at all? Truly anything that you will answer.
Yes.
Okay, here's my question. Would you like some toast?
So, and then it's going to be going off and doing the little toast sequence as well.
Did someone say they wanted toast?
And it butts in like that. That's kind of the point of it. It's always listening for that trigger word, and it will then start saying things. Yeah, so there we go. That's pretty much it. So there we go. Has anybody got any questions?
Yeah, does it ever loop back on itself? Does it get enough a positive feedback loop and starts talking to itself?
Yeah, fortunately, it doesn't listen to itself. It kind of gives up on that. I did actually have to deliberately tell it to wipe its buffer when it finished playing stuff, so it didn't recognize things that it just said.
Right.
That was a challenge at one point.
And how long did the whole project take you, like, getting going? And
Goodness knows.
libraries.
I would say I probably spent a couple of weeks on and off on it, but how many hours? I have no idea.
Yeah.
Let's just say it drove everyone mad playing some of those samples a lot.
It's a lot of fun.
Well, I was going to say that's absolutely fantastic. It does seem an awful lot of work to create something purely to annoy yourself with, though. You know?
Well, the plan is that I'm going to stick it somewhere, maybe even with a screen and a virtual toaster on it, because obviously I can't create things. But something kind of on the screen would work quite well, and then people can walk past it and it'd be a virtual toaster doing sort of saying those things and actually interacting a bit.
When you say you can't create things, do you mean as in you don't feel you have the confidence or the skills to physically model objects? Is that
Yeah.
what you're, yeah,
Physical things.
yeah? That's a shame, that, because I mean that would work really well as a real, you know, appliance, you know.
Well, if anybody's volunteering,
Possibly, we'll see. I mean, I do a lot of 3D. I mean, I do model railways, and I make things. I have a 3D printer sitting next to me, so
cool.
possibly we'll see. I don't know. It's about time, but failing that, there's always foam board, which is the stuff you buy at the craft shops, which is superb for mocking stuff up cheaply and quickly.
Yeah,
You know.
I just don't have the skills to make it exactly how I'd like it. I suspect.
Okay.
You could just buy a toaster.
Oh yeah, all that. Yeah, all
They do come in red.
Yeah, but I'm too much of a perfectionist. I want it to look exactly like the toaster from Red Dwarf, and it just won't be. If anybody's interested, all the source code and JSON files and all the rest of it are on the GitHub link that I've got there. So you can see all three versions. If anybody wants the sample files, drop me a message. I'm not going to publish them, but I don't mind giving a copy here and there.
Well, just looking at the voice library you're using, one of the options on there is to use WebSockets. I think, how about a virtual toaster on the web, which you can talk to?
Wow, that would be an interesting one, wouldn't it?
You'd have a little toaster icon on your screen, constantly listening.
That sounds truly horrific.
A bit like the paperclip out of Office, then. Yeah.
Yeah, if you've ever watched the episode, there is references in there to first degree toaster side.
Yeah.
Thanks to how annoying it is, and a lump hammer.
Yeah.
So,
Excellent. Thank you very much, Mike. It was really good. Very entertaining.
A quick question. Are you driving the speaker directly from that board?
Yes. Yeah, it's literally plugged in. Hang on, let me just. I have to lose my network connection to it, I think. There we go. So that's the board. That's the speaker.
Okay, cool.
Literally just direct connected onto the board. Your driver, I think it's 3 watts. I think it's reasonably powerful for what it is. I mean, it's pretty loud in my room. And so that's running on a Pint 4 in this instance. Will run happily on a 3.
That's very cool. Did you find that with your blue microphone, was that any more accurate than using the mic on the board?
No more accurate at all. If anything, less so. It was far more directional. I mean, it's intended as a directional mic, so I've got to speak into it to make it work. Whereas the 2 and the 4-way speakers are intended as a room level audio and will work from several meters away. But if I went more than a meter from the mic from the Blue Yeti, it just didn't work at all.
It's cool though. Smart project.
Something quite random, but I like random projects that teach me something about like voice recognition. How am I going to do this? If anybody's interested, the Snowboy library you have to upload it to them, and they're shutting the project down at the end of the year. But it's really, really good if you want something just tied to you. So if you want to make some voice recognition with some keywords that only work for you, go and generate your keywords now, because you won't get a chance to make them again later.